So welcome, Farrukh, and thank you for agreeing to present your wonderful work on how geospatial tools were instrumental to promote transboundary water cooperation in the Mekong Delta. So I'm gonna let you share your screen and you can start.
Yes, thank you, Frederick. Just a second.
Take your time.
Yeah, here we go. So can you see my screen now?
It's starting the screen share, so it's gonna come up in a second. There we go. Yes.
Okay. Hey, good morning, good evening, wherever you are. Thank you for the opportunity to present at this event. And I think the spirit is quite on the right track, that we need to work together to address transboundary issues, including those of water. From just a brief introduction on my side, I have been involved in research for more than 20 years and worked on disasters for more than 17 years and across South Asia, South and Southeast Asia, as well as now here in North America. The work is continuing. And this talk is actually born out of our collaboration with the Peace Innovation Institute and UBC. And Peaceful Society Science and Innovation Foundation that I've formed actually is based out of this mission to actually advance science and innovation for human and non-human good. And with that, I will showcase, spaceborne Earth observations as those types of technology and science that can help us advance as humanity and help the poor, help those who are the marginalized and vulnerable communities. So this is the outline of my talk. Basically, I'll outline some of the dangers related to climate change and its increasing impacts. As a climate scientist, of course, I'm really concerned as how we are continuing to warm and continuing to emit, and the intensity and the frequency of these disasters are only becoming worse. And with that comes the urgent means for us to act. And one of those actions I think is very important, is that we collaborate and work together in order to deal with our differences. Earth observations are a key. Satellite-based information is one tool that can really help us out of this crisis, this existential crisis that we're facing. And in that, I will share a very productive and a very how should I put it, global effort on actually which is a NASA and USAID collective. I worked with them for 5 years to actually bring to translate and incorporate Earth observations, which are very high-end science, to actually actual users who down to the very people at the village level. And I will share as a case study how we were able to deliver to the Mekong River Commission to improve their riverine flood forecasting. As floods are one big climate impact that we are witnessing right now, amongst others. And with that, I'll conclude my talk. So, as we all know, and as you've seen, recently, of course, yesterday, we had a synthesis report for the IPCC 6th assessment reports. And the only simple thing, is that we need to act. I mean, we have a lot of good technology and good science backing that up. And what is missing is, of course, both on the side of mitigation and adaptation. And more urgently, we have to act in ways where both of these help us out of this crisis. And, there is a report by UN which showed that floods are one of the worst disasters. They have affected billions, and still, you have probably, the thing is that in Pakistan recently, 35 million people were affected in the 2022 monsoonal floods. And again, those are induced by climate. As you can see, again, the disasters are increasing, and we are, being hit with climate impacts, which are floods, droughts, extreme weather events, landslide, wildfires, you name it. And with those increasing disasters, we have to have this balancing act of also working with both mitigating, reducing our greenhouse gas emissions as best as we can and as soon as is possible. But at the same time, also work with the reality that we've warmed the planet enough, so we'll have to face these disasters, for decades. So with that in mind, climate change impacts are here, and we are seeing, as you all witnessed, that the very hydroclimatic impacts are increasing. And we need both adaptation and mitigation to build resilience against climate change impacts, which are happening globally. And Earth observations are both useful and important because they, of course, provide insights into Earth processes and phenomena which you can't get from point observations or on the ground, technically speaking. They fill and complement different data gaps. And, with respect to countries that have scarce amount of data observations, we can complement and fill those gaps. And this talk will highlight how we can do that. One example, very key example. The great part is that NASA, ESA, JAXA, most of these data sets from the space agencies, the Earth observing satellites, are available for free. And again, they provide data for regions that lack ground observations. And we can build early warning systems to these disasters, which can again help save lives. The satellites have been long in space, so we have 30-year data sets that can help us do climatologies with them. So we are actually living in an era where, this is very useful for addressing many issues that we're facing right now. As you can see, there are many such satellites looking at different sectors of, different systems, Earth systems, if you will. There are satellites that measure, precipitation from space. There are satellites that measure clouds, their properties, aerosols. They would look at ocean surface temperatures, and salinity and whatnot. So a lot of these satellites are providing us information that in the context of a changing climate, help us understand and then help us sort of build that into our existing system so that we can deal with the climate crisis in a very informed manner. Because a lot of our usual models, including the weather models, aren't up to it. They're not actually, they don't get the climate impacts in the way that we usually get the usual weather reports or some of these, the intensity and the frequency of these disasters. So these are real-time data sets, or that we are observing right now from space. And again, a lot of these are free for the public to use. The European Space Agency is another example. They have invested a lot in this technology, knowing with the vision that this would help us manage our resources. The planet is finite, and of course, with the changing climate, we need to observe Earth to understand what's going on, because in a changing climate, our usual understanding of and models are not working to the extent that can help. So with these satellites, we can refine and actually work with and fill, in many countries which are poor, which are vulnerable, they don't have the infrastructure or the capacity to conduct, to have all these ground observational networks that you have in Europe or in North America. But how these satellites can help build that gap, because of course we are all interconnected and they're also part of this. So how do we build that, especially with the poor and vulnerable nations? So with that, countries around the world need satellite data right now. I mean, this is just across the board, and more importantly, the poor and the vulnerable nations. And disadvantaged and marginal people, as you know, are most affected. And the satellite data can help partner in countries and to identify and manage climate risks, right? And then this is a good meeting point for countries that actually have transboundary issues, as I will show in my example. So I wanted to introduce SERVIR, which is a joint NASA, USAID, and project, which is basically bringing satellite data and geospatial technology across various hubs they have across the globe, across Asia, Africa, and Latin America. And they are addressing critical challenges from climate change, food security, water and related disasters, land use, and air quality. And the good part about this is that I will show that we work with our partners in order to build custom-made solutions that fill their needs rather than just provide them data and say that this is for free. We work with them to the extent that in co-development, we learn from them, and at the same time, we also try to do new things. New ideas also emerge from crisis, so we are able to build new methodologies that ultimately are best suited to their needs. And as you can see, we have a lot of partners. The SERVIR, as you can check out SERVIR Global at this website, and these are the 4 sectors that SERVIR is typically, involved in. As you can see, water and water-related disasters is the relevant one right now, but there's agriculture and food security, land cover, land use change, and ecosystems, as well as weather and climate. Those are 4 areas that SERVIR is working across its various hubs across the globe, and these are the regions that SERVIR is involved in. Of course, they're based out of the SERVIR Science Coordination Office, which is based out of Huntsville, Alabama, and their headquarters are in Washington, D.C. Along with NASA, and the thing is that they are working, through SERVIR Amazonia Hub, which serves Latin America, and then SERVIR, Western East Africa, Eastern Southern Africa, as well as SERVIR-Mekong and SERVIR Nukush Himalaya. So with that coverage, you can see that it works in more than 50 countries and can help out in many of the issues that you're facing with satellite and geospatial technology. And of course, with that coverage, there is encounter of transboundary issues. As an example of how powerful this network is, they have collaborations from across all very powerful scientific, academic and industry partners. These range from, Michigan State University, University of Wisconsin, Madison, as you can see across the board, to Google, Esri, Mapbox, NASA, of course. So with all of that firepower, they're able to bring the best to these countries that have gaps in their measurement. And of course, all of this stuff is needed here in North America too, as I would like to emphasize, because again, with climate change, nobody is exempt from it. There is a lot of partnerships that, as I was sharing, SERVIR has. And as you can see, FAO, World Food Program, Red Cross, Red Crescent, Mercy Corps, very, key partners, from the industry, from the USG sector. And then, of course, there are consortium partners as well, regional hub institutions. So with all of these partners, the aim is to reduce poverty and increase resilience. There are issues with data. How do we bring about, the data in data scarce places? Presence in the international internationally as well, and there are 30 plus Earth observing satellite data missions for which SERVIR brings custom-made solutions through its scientists and and technical experts. And there's a major research portfolio that you can check out on their website. I will just show you one example, but you will see many such cases. And again, the idea is to bring the societal benefit from space, which is really important and critical at this time. So there are some distinctive aspects of SERVIR, which I will try to highlight and in my example, but just to let you know that, with respect to satellite-based technology, it's not that these technologies didn't exist before SERVIR, they did. And there has been quite a long time where, scientists and experts have tried to share this information through various tools. But the lack was actually just this siloing of information or tools that were just basically developed without taking any user feedback and basically understanding the local context of what, just giving somebody data or something that works in your country doesn't mean that people, in different region or different part of the world will understand or necessarily adopt. And in that, SERVIR is completely demand driven, so we make sure that the user reaches out to us rather than us hammering that message home that you need satellite information and must do it. The other part is, of course, we co-develop. And the thing is that that's where, SERVIR is very open in terms of understanding the needs and learning from our partners so that we provide the best available science. And NASA has, of course, a great legacy of Earth observing satellites and science, along with other US partners and other international partners, so that we can work to solve these issues. It, of course, is very inclusive. Our services must be accessible and represent the needs of the women and indigenous communities, the poor and vulnerable communities. And of course, with respect to our plans, we want them to last, we want them to sustain. So trainings and capacity building and resources are very key, because we don't want to just give them, a custom-made solution, but also so that these agencies or these whoever we're providing the service to actually learns the back end of what we have done so that they can manage and improve it on their own in the future. So with that in mind, we have a so-called service planning approach where, first of all, we take into, the demands of what our user wants. With that, we provide, we look at the appropriate geospatial data tools. We consult them on a regular basis, understand where co-development take place, and devise based on the solution. We look at the outputs and outcomes, which are, shorter term goals towards a longer term impact, so that, in the 10, 20-year time frame, where will that solution lead them to? And we develop a theory of change with them. And again, this is not a linear thing, it's an iterative. We keep coming back and refining our approach so that we reach that great impact that we're looking for. And an example of this was when I was working in SERVIR-Mekong in Thailand. We received this call from the Mekong River Commission to improve their riverine flood forecasting system using Earth observations. And with that, I was working in the SERVIR-Mekong hub at the time as the science and data lead, and we already had a lot of, you can go check out our website. The thing was that we already had a lot of data available for the general public. This is, again, NASA-derived data sets that provide you radar-derived, satellite radar-derived virtual rain and stream gauge information. We had climate data. We had data to look at, various vegetation levels at the SERVIR-Mekong. But again, they were asking us to look at floods and how their system could be improved. So we had to go and work with them. And this was, again, driven by their demand. And so the problem statement, as you can see, simply is that there's limited rainfall data that leads to inaccurate global estimates. And then that leads to inaccurate flood estimates. Ultimately, they have an unreliable early warning forecasting system or early warning system, which lead to losses. And I think this is, again, exaggerated by an increasingly changing climate. So we need that real-time information so that we can stay, our predictions are as close as is possible to reality. And so with that, when we started our consultation with the Mekong River Commission, we showed them our capability. We had various satellites that could help them with the precipitation levels. And what we recognized soon enough was that the issue with Lower Mekong Basin and the river basin is that there are transboundary issues where they lack this information. They don't have enough rain gauges, to cover. As you can see, in some parts of the of Lower Mekong Basin, there's very little. I'll show you in a later map that the coverage is still quite sparse. And with the satellite data, we can get a 10 by 10 kilometer resolution pixel sized observation, which far does their measurement capability. And of course, in a near real time manner, which beats their an hourly level, which beats their usual daily information from a rain gauge or a stream gauge. So with that, we like as mentioned, we were reached by the Mekong River Commission and the Regional Drought and Regional Flood and Drought Management Center of the Mekong River Commission is mandated by 4 countries to help with water and environmental related issues. And so those member countries are Cambodia, Laos, Thailand, and Vietnam. And the flood forecasting system is based on a modular hydrological hydraulic model so that it creates short and medium early warnings for each member country. And basically it operates in the flood season, but it provides, which is from June till October. And then in the dry season, it provides weekly forecasts for these countries. So with that, basically, they wanted us to upgrade their existing system from, a previous NASA JAXA mission, the Tropical Rainfall Measurement Mission, where they were using this data, to the Global Precipitation Mission Measurement, Global Precipitation Measurement Mission, GPM, which was far superior than the previous mission. And at this time, they reached out and they said, we don't know what to do, how to adopt to this new technology that is coming out. And the thing is that, as you can see, there's a 3-hourly time difference, the measurements are 30 minutes versus, 3-hourly. From TRIM, the spatial coverage is better. And so they were saying that we need this to this shift. And with respect to that, the NASA JAXA mission that I'm talking about, the Global Precipitation Measurement Mission, is the leading technology based on a dual frequency precipitation radar that far outdoes its predecessor. And again, this data is available for free. And it is done in consortium with other rainfall measurement missions. So it's a global mission, which leads to a product that is available at a 30-minute latency, a 30-minute difference. And so with that, we had access, and we have this data available on the website, but how do we work with this data in an operational sense was the challenge. And I can show you what those challenges are. Because there are, of course, errors in rainfall data. We are scientists. We don't want to do this, just feed the satellite data in and then hope that it works out. Satellite information is susceptible to systematic errors too, and there's no doubt that rainfall estimates from satellites suffer from these systematic errors. And this depends on the type of sensor. If you have a passive sensor such as infrared sensor, it has a different type of systematic error. And then if you have a radar, which is an active sensor, it has a different type of response. And then it depends on the surface condition. typically there are issues related to how it will measure, from the mountain to the lower flat areas. It also depends, these errors also arise from the type of event. If the more extreme the event is, the satellite misses it or doesn't underestimate typically. And there are random variations of the rainfall as well, which cause these errors. So how do we account for these errors and work with that? So basically, we devised a bias correction of the GPM satellite measurements so that we provide the best available near real-time GPM data to help with this flood forecasting system. And we, as I shared, we have the virtual rain and stream gauge information service, which again gets this data, and then we have a bias correction tool that works with their flood forecasting system, the Delft Views forecasting system, to provide the best available flood forecasting. And so our objectives were, first of all, to see what is the performance of these bias correction methods to improve the accuracy of the precipitation measurements from space over this region. And by that I mean bias correction means, how do we incorporate ground truth in order to improve the accuracy of the satellite itself, which is the information from the grain gauges themselves, and then develop a tool so that it corrects this on a daily basis, working with their systems. So there are different types of bias correction methods, and the Mekong River Commission was using these two. First one actually just corrects for the mean and the difference between the variation of the satellite information data sets with the ground information. And the other one uses spatial interpolation. This is all very technical, but I just wanted to say that, again, this was an opportunity for us scientists. And I was the lead, and I sort of said, okay, we need to make something even better than this. And so we developed something which is the spatio-temporal distribution transformation approach, which also takes elevation and height into account. And that in of itself, we hypothesized at the time that this would actually, we should check it out and see if this taking into, because we knew that satellites actually underperform with in areas of higher elevation, such as mountains, etc. So with that correction into account, we have proposed a new approach altogether. And the challenge, of course, was getting data on doing this demonstration as to which bias correction approach to go for. And as you can see, the MRC stations themselves are quite sparse. Those are in yellow and red dots. And Thai agencies, though they are part of the MRC network, they don't share data. So it was quite a challenge to work with them and they have far more coverage. So what we did was we looked at a period of 2014 to 2018, all the monsoon seasons. We had 129 daily rain gauge data stations on the MRC, and then we through a lot of dialogue and discussion, as well as consultation with the Hydroinformatics Institute from Thailand, we were able to get data to validate as an independent data set from them, what we are doing with MRC. And with that, we were able to show that the overall correction from the bias of the satellite-based information from the bias correction actually improves it from 50 to 1700%, which is tremendous. And, again, the validation increases, from 2 to 70%. These are correlations. With respect to the overestimation of the accuracy, again, we saw that the newly proposed spatio-temporal distribution transformation produces better results than the rest of the thing, because they had the lowest bias and the lowest errors. So we saw that in the satellite-based information, but basically we saw that there was a 25% improvement when we include this, which is very substantial. So with that, we also wanted to check whether it works with the model that with a model to check its hydrological sensitivity analysis, because all of this has to go into a hydrological model. So we looked at a case study of Vientiane. There was a flood there in 2019. And so with that, we measured how, the distribution transformation bias correction approach worked, which was good. This was a little, didn't perform as well, the spatiotemporal bias approach. And our proposed approach, the spatiotemporal distribution transformation, worked best. So with this development and demonstration to the Mekong River Commission, we developed an implementation scheme where, instead of the previous TRIM, we brought in, we are bringing in the new, the global precipitation, near real-time data sets. We changed their previous bias correction approach to the approach that, the new approach that we have. And we then correct this bias, this rainfall bias corrected approach, and feed that into the hydrological model. And with that, we developed a Python-based tool that worked with, provided them all the available bias correction methods that they had, the previous ones too, for their choice. And we adjusted them to work with the the MRC, so that involved working with them on ground. And, again, they could check out the performance, because again, satellites actually do have errors, and we are working with that understanding. So here you can see, where we would go there on a regular basis, and this is one of the meetings where we worked it out with them, where we explained things to them and worked in there at Phnom Penh, Cambodia. This is one of the days where we went and presented the tool as we developed it collaboratively. And overall, we were able to evaluate the performance of, and applicability of GPM. We found that it needed bias correction. We then evaluated the capability of various bias corrections in agreement with the Mekong River Commission, so that we improved the accuracy of the satellite-based information. And again, developed an operational bias correction tool so that they can, that it feeds reliably into their flood forecast system. And, with that, this is, we were able to, the MRC, it was a successful uptake from them. And this success was, of course, highlighted in the SERVIR Global, is by SERVIR, and of course, really appreciated by the MRC, where we were able to successfully operationalize, satellite-based information into their system. And this work is ongoing. We are also helping out with their drought monitoring system. That's another case study, but nevertheless, climate change is a call for us again to bringing in, new ideas and improvement in existing practices to address with this terrible crisis. And so with that, I also wanted to highlight that data sharing is, some of the things, as I shared, can be very challenging. It took us a year to get through even the agreements on, whether this data will be not used or abused by us, or, because when a US-based project comes in, there's a lot of skepticism there too. And you have to recognize that, of course, a lot of governments have denied climate change. So, this inaction also leads to, delayed science. And in that, ethical considerations of where your partner is really important. So I would like to conclude that Earth observations will play a great role in addressing climate change. The space agencies are sending newer missions, and we need to stay on board with them. And water is a great, of course, water is life. So we have to, we have to, again, keep abreast with the latest technology in order to serve our communities. And, political influences and climate action are important drivers. So, we have to bring that message home that we have to act for the sake of the planet. And innovation and science, particularly directed in these areas, not for the dangerous kind, that's what the Peaceful Society is saying, or Peace Innovation is saying. We should direct this, and satellite information for the sake of helping our decision-making processes in the era of climate change will make all the difference. With that, I want to thank you, and you can reach me out at my email. I also wanted to share that I am not officially with SERVIR right now, but I can direct anyone to them for further collaboration. Thank you.
Thank you very much, Farrukh. And we already have a question from Sherilyn, who mentions that she read about a scientist on an icebreaker in the Arctic, woken up because he realized that it was much faster than expected because the ice was thinner than shown by the satellite data. So yes, there is a value to being on site. And in answer to your question, yes, we are absolutely, Sherilyn, considering working with First Nations peoples. I'm working with the Squamish Nation in BC, for instance, on a project. And yes, we also are considering citizen scientists.
And I think what my case showed is that we, as scientists, are skeptical about satellite-based information. So what we do is we combine the ground and the satellite in order to produce something better. So that's what you saw. But nevertheless, we have to be open and transparent when the errors are large. And if the errors were unmanageable, we wouldn't have gone ahead with it. So we were very careful in managing expectations of what this technology can do. But, you know, of course, the missions are designed with a lot of science and technology testing and validation. So if it's within acceptable range of errors, a combination would be a great approach, because again, we use the local information in order to correct the satellite information to get better. Yeah.
Noted. Are there any other questions, comments, ideas you'd like to share? Please put them either in Q&A or chat. I have a question for you, Farrukh. So what would you say is the number one avenue that was taken on by the countries of the Delta, so Cambodia, Laos, Vietnam, Thailand, in terms of all of this available data sharing? What would you say is the most successful, if you know what the most successful endeavor they've pursued jointly?
I think they already have a mechanism in place. And what this satellite information they are, as you saw, Thailand doesn't share, a lot of its information at times. So what it opened was that, this satellite data is already available for free, and, it's out there. And they could not deny. So I have to credit NASA and ESA and all these space agencies who have, first of all, not close this. They're sharing it, across various platforms and their websites. And so with that, I would say that this opened that door where they said, okay, we already used this to some extent, but the thing is that we never did it scientifically well enough and did not share information. So the satellite information opened that issue of why weren't they sharing this transboundary, information. And right now, MRC is, working collaboratively with Thailand to share the ground information. So what this satellite information did was and we were appealing again that all of this helps the region. So it sort of has had a very good unifying effect, where they said, okay, if everybody else is sharing it, what's the point of us sort of holding back? I also would like to highlight, of course, China from the north does withhold information. That's also with the upper Mekong region. So that's another issue that we are working with various agencies there. But the point is that the number one thing that it opened was that, yes, we can move forward by sharing information. And if NASA and ESA and all these people are sharing it, why not us? And I think that way that whole issue of transboundary sharing, which is a huge issue, because again, security and all these different reasons are provided as an example. But with lead forecasting times getting better, this was a matter of the people in the region and their security. So I think that brought us closer to that sharing, and those doors opened for Thailand to start sharing stuff too. Yeah.
Excellent, thanks. So I know that we have some folks in the session right now from Southeast Asia. If anyone wants to share what you see as challenges or ongoing collaboration across boundaries, that would be ideal. I know, for instance, I think we had someone earlier from, yeah, Roy, I don't know if you're still connected from the Philippines. If there's something you want to share, I'll open up your mic if you want. If you don't want to, that's okay too. But I thought it was potentially interesting to hear from folks who are on the ground there, because there may be other areas of the world where this approach can be used. And the next session that we'll hear in about 20 minutes will be on the lack of cooperation between two neighboring countries, the United States and Mexico. And what I find a bit ironic is that NASA and USAID have been funding this very worthwhile research in the region of Southeast Asia, but the same type of collaboration will get exact information on why is not being deployed in their neighborhood between the US and Mexico.
Yeah. And my in regards to that, Frederick, as we discussed, SERVIR can help out because they have presence in Latin America. And what we can with SERVIR Amazonia. And I think if we bring that up with them as another area to consider with a service planning approach, getting to know the stakeholders on both sides, where the issues are, what type of information can help them, how do we combine it for water resource management. A lot of satellites help with that as well, with respect to droughts and floods that they may be facing in the region. I think that could be a really good way in which SERVIR can get involved. Again, it's very interesting because, these organizations are often siloed,
They
as
are.
we noted that they're working internationally and providing that really great service, but sometimes, local agencies don't even know and talk to each other. So that may encourage that de-siloing. And again, I am in contact with them, so we can work on forwarding their issues to SERVIR. Yeah.
Wonderful, wonderful. So we have about 15 minutes before the next session. If there are some comments, oh yeah, Roy is commenting in the chat and saying it's different. Yeah, but if you want to share the archipelagic issues, Roy, I'll give you access. Hi, Roy.
Hi, good evening.
Hi.
Good evening to everyone.
Yeah.
Well, as you probably know, we're from the Philippines. We are an archipelago together with Malaysia, Indonesia, East Timor. So these are the parts where there are large and, well, mostly small islands. And our situation here on freshwater in particular is very different. Because each of our aquifers are, in each of the island. I'm not actually aware if there is a common aquifer across these countries. We have not really thought of it that way, being islands. What we do share is a lot of seas, and you are probably aware of our difficulties nowadays with West Philippine Sea, and the Chinese would call it differently, but we do have this struggle against defending our conflicting claims, no, on the
Right.
common water. Our view in the Nature Party Philippines is, of course, moving towards more solidarity in neighboring countries in Southeast Asia to resolve this dilemma, security dilemma.
Right.
But of course, we are talking about fresh water, and in our case, the concerns are really more of smaller watersheds. I'm part of a local governing board of our local WACMA, Water Quality Management Area. We have in the Philippines, we have a Clean Water Act that creates this WACMAs as management bodies, and there are many of us who are part in intergovernment and multi-sectoral governing mechanisms such as this. But you are, I think, fully aware of the rate of our deforestation and forest degradation, our high rate of urbanization, and still population growth, although we have declined a bit recently, but the rate is not fast enough to, and of course the in-migration from urban to rural, even if our total population is not really no longer going up, but the in-migration is so fast that there are now very large cities that create such pressures on watershed areas. No, for example, in metropolitan Manila, which is the capital, 30% of our population are all here. It creates pressure for setting up large dams in watersheds that are within near metropolitan Manila, and these dams are of course opposed by many upland local communities, including the indigenous people. But of course, one of our difficulties here is, of course, the divide and control tactics that are also being used against indigenous people's community. So one particular tribe recently was broken down into several conflicting units across clans of family, on the issues of large dams. And this is China-funded loans, and in a way, it's a huge issue because this is a water embankment system that's supposed to secure water for the next few generations for Metro Manila. But of course, this assumes that urbanization will continue in the same rate. We in the Makakalikasan Party, we believe that it's time to de-urbanize. And this assumption of really continuing growth in cities is a wrong projection, if you ask me, because it assumes that it should always go up, and therefore it justifies all this, well, to our point, more of a development aggression, and at the point of being called a development aggression, because it's affecting cultures and communities, and it's dividing peoples right across in the middle. And so it's really different, but we do appreciate presentations that have been made here. Of course, the use of technology, satellite technology. This we also use that to some extent here, but the transboundary nature of water conservation is something interesting to us, although our context is different. No? But if there are information about common aquifers that we actually share, I'm not sure if that's really our situation here, being archipelagic. We do not have big rivers that cut across these islands. Probably in Malaysia or in Indonesia, there would be. Today, until in the next 3 days, we have a national river summit here in the Philippines. All the literally all the stakeholders and river conservation in the Philippines are in one venue talking about the various issues. But compared to other countries, our rivers are relatively small, and these, of course, are also composed of small watersheds. So to us, in a smaller in a smaller context, the information shared here and the insights are still very relevant.
Right.
Sure, Frederick will try
Yeah.
to
Thank you.
share. Just give me an email where we can send it,
Sure.
and we'll
I'll just
try
put my
to.
email again, and we'll be happy to have the sharing of findings. So thank you, Roy, for sharing this, and I also want to thank Christine for sharing the map, which I'll share again, which is in the chat, of the transboundary aquifers. So you can see the map is really interesting, and it shows the potential conflict areas that we just talked about in the Mekong Delta. And you mentioned, of course, China not sharing data. China
Right.
has dammed, has
Yeah.
put up dams pretty much everywhere.
Yeah.
And therefore, that definitely creates an issue for the downstream folks.
Yeah.
Yeah. All right, so we've got 10 minutes left. If you have any more questions and or comments or things you want to share, please do. If not, we'll take maybe a 5-minute break between the two sessions. We want to thank Farrukh for his wonderful presentation. And I think, although it says my name because it's one of the links I originated, this is Jorge Preciado, who's going to present his colleague Ana Cristina's work on US-Mexico. Jorge, that is you, right? Because I didn't sign in twice, so it should be you. Let me just... I'll end the recording for now, and we'll start it again later.